Hello, it's Nigel Bowden here, and I was just wanting to put together a quick video to show you an interesting technique in Wireshark to try and figure out the data throughput of wireless clients. I've been looking at various video formats streaming over Wi-Fi. Just to understand the amount of data which is consumed, and saw some interesting facts that said that 4K video requires bandwidth of around about 25 megabits per second, which is a reasonable amount of bandwidth and airtime to eat up. And I just wanted to actually have a look for myself and verify, the level of data that it might actually consume. So I thought the best thing to do was actually get my Samsung phone. You can see from the title of the file in the corner there, it's a Samsung S7 phone, and I was actually streaming a 4K video stream from Amazon Prime. It was a fairly new TV series that was streaming in 4K. Interestingly as well, you can see it was actually going over 2.4 gig in this particular case, which is quite interesting. Wouldn't be my first choice normally, but that was the environment that I was working in. So what I decided to do was actually take a over-the-air capture of the stream, well, of all data on the channel, and then filter out the data frames that are going to my device, and then from that try and derive the throughput of the actual data that it's pulling when it's taking the video stream. So you can see I've got a Wireshark capture here. In case you're not familiar with the colours, the coloration scheme that's used here is purple colours. It designates management frames. The orange coloured frames are control frames, and the blue are data frames. And this is a colour scheme that's borrowed from the MetaGeek IPA product. They actually used this within their product, and they created a profile, a Wireshark profile, which they've shared with the community, and provides a nice set of sort of visual cues as to what's going on at a glance. Now, I've also got quite a few different columns which I've created just to give me a bit more information to show me what's going on at a glance. So what I'm interested in initially is trying to find a section where we start to actually stream. So I'm looking for streams of data frames. Here we go. I think this is it. You see all these blue data frames. They're coming from this Belkin MAC address, and they're streaming to my phone. I've actually got a name for my phone in the application here rather than the MAC address. If you actually edit the ethers file within Wireshark, you can actually add in custom names there to translate into a real name, in the same way as you do as an IP hosts file. So first thing I want to do is actually filter out all of the frames that I'm not interested in. I'm just purely interested in the data frames, because those are the ones that are actually shifting the data. I'm not interested in any of the management and control stuff. That's all just overhead. So the easiest way is to actually select one of these data frames here, and I will just go down here, find the MAC address here, which is here, destination address. If I right click on that and then do apply as filter, I can actually just click selected, and you can see it actually populates at the top here in the filter bar. It actually creates a filter automatically for me, so it saves lots of typing and mistyping MAC addresses. And you can see that now the actual frame display is just showing a filter which has got the destination address for my S7 phone, which is just what we want to see. We see lots of data there. Interestingly, if we actually look at the length of these frames, they're all fairly long. They're over 1600 bytes. That's the actual length of the entire 802.11 frame. But what I've also done is added an additional column here, which is just the actual data payload. I've called it data.len, but if I just go back down to the main decode area here, you see this the data field at the bottom here. At the end there's a summary of the length of the actual data payload, and I've literally, just by doing a right click and then apply as filter and selected, I've just figured out what the name is of that particular field, and it's data.len. Which we'll come back to later on. Okay, so we've got all of the frames that we are interested in, and what we need to do now is summarize them in some way to actually get them to show us what's going on over time. So the best tool for this, or one of the best tools, because it's free, is within Wireshark. You've got under statistics, you've got the IO graph feature. So if I click on that, then that actually brings us up this graphing tool, which is very, very nice. Takes a little bit of getting to grips with, and it's got a few little interesting features, shall we say, but it can be very, very useful. So by default, it gives us these two graph traces, all packets, and TCP errors. We're actually just going to disable those. We're not particularly interested in those. What we want is we actually want to display the data frames which are previously filtered. So what I'm going to do is just very quickly go back to the frame display there, just copy that display filter, and I would do, there we go, copy the display filter and then go back to the graph plotter, and then all I'm going to do is pop that display filter into there, and I get an option to change the colours as well, which I'm not too bothered about doing, but there we go. And what I'm going to do now, let me just make this a bit smaller and pull it up so you can see what's going on at the bottom here. Just resize that very slightly. No, it's not going to let me. There we go. Yeah, so I've actually put the display filter in there. I've done nothing else, and I'm literally going to hit the enabled button there, and you can actually see it is now plotting the number of packets per second, or frames per second, in the graphing area. The reason I know it's packets per second as opposed to packets per minute or anything else is there's a very important drop down here which is called the interval, and by changing this you can actually determine how often how the samples are rolled up in the display above. And because we ultimately want to get to number of bits per second, I'm showing a display which is showing an interval of 1 second period, and you can see we're sort of streaming up to if I hover over the peak there, if you look down in the bottom left, I can't point two places at once, but there we go. If I just put my mouse down there, you can actually see there's a value down here. If you watch that as I hover over the peak there, that goes up to 1724 packets per second. So that just gives us an idea of what the value is. But we're still not really there in terms of understanding the number of bits per second. So what we need to do is actually modify things. We want to convert from packets into bits. So the next thing I actually want to do is, if you think back to the data length field I was talking about earlier, I actually want to every second I want to take all the values that occurred within that second and add them all together and then plot that, and that will give us the number of, that initially gives us the number of bytes per second because the data length field is in bytes. So if I select the sum y field, and here I actually put in that data.len, so this is the length of the payload in bytes, and then what we actually get at that point is something which is starting to look a little bit more interesting. We can actually see the number of bytes per second because we know that the data length field is in octets, number of bytes, and we're plotting the sum of all of those data frames in a 1 second period. And so we can see here now we've gone up to 2.25 million. In fact, if I hover over that value there, we're actually up to 2.602 to the power of 6, so that's 2.6 million. So it's 2.6 million octets per second. So if we want to convert that now into bits per second, I've got my trusty calculator here, so we've got 2.6 million, which is going to be 2600000. There we go. And now if you multiply that by 8 to convert from octets to bits per second, it actually gets us up to 20 million bits per second. So that's about 20 megabits per second. So we can see that at a peak we are sort of hitting something in the order. It's not 25 megabits per second, but we're certainly shifting some fairly hefty data rates there. What is interesting is the general shape of this, and one of the things that I read is that when you're streaming from services like Netflix, it tends to be topping up a buffer constantly, and you can see that behaviour here. It's sort of falling and rising, then falling off. So we're sort of topping up a leaky bucket all of the time, but it is one sort of way to look at it. So it's interesting. It's not a continuous, certainly not a continuous 20 megabits per second or even 25. It's sort of variable rate, but it is still pulling a fair amount of data. Another interesting thing that we can do with this, if I actually copy that, so I'll call that graph there. What should we call it? Data to S7, and I'll call it octets. There we go. And then what I can actually do is copy that. Let me get rid of this one here. If I just get rid of that, I can highlight that one and then duplicate it, and we'll call this one frames to S7, which is pretty much the original graph that we saw. So I will change this back to, I'll get rid of this field here and change that back to just display the number of packets per second. And I'll switch off the octets one. So now we can just see the packets per second, which is quite interesting. We'll actually change this now to a bar graph. And we'll get an update there, so we can see it in bars, which is interesting. But the thing that I'm quite interested in doing is actually comparing that to the number of retries, because obviously the number of retries is something of great interest, because we can see how well or poorly the network is performing. So we'll do retries to S7. What I just need to do is change this filter to include retries, and for the life of me I can't remember what the filter should look like, so I'm just going to go back and use the old trick. So this time we're actually going to look in the frame control field here, and if we look under the flags we can see whether or not this is a retry frame. So I'll just do prepare as filter selected, and we can see that this is the value we need to put in, but we actually want that to be a 1 to say we've seen retry. So if I now put that back onto the IO graph here, this should theoretically show us the I do and retries there. Okay, and what we'll do, we'll just change the colour of that one so we can see what's going on there. There we go. So now you can see we've got these two plots enabled. So we're seeing the frames, which is the blue. We can also see the retries at the same time. So we can see, yeah, we've got a reasonable level of retries there. It's probably not as good as we would like to see, but obviously just bear in mind that this is on a home network, and of course it's on 2.4 gig. One final thing which is very interesting, obviously understanding the number of octets per second and converting that with a calculator is not the greatest thing to deal with, but one very useful feature that we've got is at the bottom here. You've got a save as, and what you can actually do is you can actually change that to CSV format and then save it, and then you could open that up in something like Excel, which means you can make a nice little report out of it. Anyway, so hopefully that's been of use to you. Probably gone on slightly longer than I hoped, but it's quite an interesting topic, and it sort of shows the flexibility that you've got with a bit of filtering and using the IO graph feature. So hopefully this has been of some use, and if you've got any feedback, just leave something in the comments, and I'll also post a link in the notes field of the video to tell you where to get the Metageek coloration profile if you'd like to get this nice colourful display for Wireshark for yourself. Okay, anyway, thanks a lot. I'll speak to you again soon. Bye.